Okay, so once again, good evening, ladies and gentlemen. Thanks for having me here tonight to share a little bit more about XR with you guys. So from what I understood, this is a games club. So I think you guys have already kind of understood what XR means because this term might have come across your research from at some point in time, right? So this is what I'm going to talk about. Just a quick table of contents, introduction to myself for starters, and then a quick glimpse into what is XR and why XR. And then I will share a little bit about current landscapes, latest trends, and also the future of this space. So introduction to myself. I think some of you might have saw my name. You can call me Lloyd. And basically, I graduated quite a few years back, and I'm a digital graduate. I am formally trained in game design and development. So I'm a com science major. And following up from my graduation, I was looking for startup experiences just to really learn the whole using tech as a business model kind of concept, right? So I looked around and I found this company. It's Singapore based, and I served 3 years as a mixed reality pioneer in this company. That was also my first foray into the whole XR space. Before that, it was really like games industry maybe, and simulations like automobile industry. And so XR was quite a new thing for me, but along my time there, that's where I really learned the most. And because in the startup we had a very lean team, and you really gotta get your hands on everything from design to solutioning to client project management, and then finally developing solutions for them. After my time in this mixed reality role, I went on to a second company and spent about a year there. In this development lead role, I mainly led the AR and VR endeavors. So that was also quite a good learning experience for me because AR and VR was something that I didn't do as much. Mixed reality was the focus prior to that. But in that 1 year, I also got a good exposure to AR and VR. So in fact, that was also the premise of where I am now, because in that 1 year, some of the projects that we did got caught a company's interest, and they were looking to develop undergo some digital transformation. So in that process, they decided to bring the entire team over to their company. So now I'm heading that department as a project lead to aid this company in the digital transformation. So that's a little bit of introduction to myself. And jumping into XR, you might have already guessed it now. To understand what XR is, it would be essential to first have the clear differentiators to what VR, AR, and MR means. So virtual reality, augmented reality, and mixed reality, right? Who here can clearly already knows the definition? Quick show of hands. No? Okay. So, well, to start things off, I like to say that AR and MR shares a very similar baseline concept. It's about bringing the digital things into your world, right? So you are in this real space around you, but now the next moment you find digital augmentations enhancing your real environment. And usually in proper context, this digital information is around to entertain, engage, or even help you in the things that you do. So VR, on the other hand, it's quite a separate concept. It's about bringing you into a digital world. So while you may be in any space in this real world, when you put on the VR glasses, the next moment you'll find yourself transported to a whole new dimension, right? So that's VR, differentiating itself from the rest. But when we talk about XR, we really looking at the concept of how all these three immersive technologies come together and extend reality beyond what they mean. So these days you see things like people talking about the metaverse and Web 3.0, how you can use VR, mixed reality, and everything, right, as a seamless experience. So we're getting closer to that, but I'll leave that conversation towards the end of this share. So let's move on to why XR, now that you have understood the terminologies. So the fundamental premise here is that technology exists to improve our lives. From the beginning of time, we have developed many different technologies, right? From simple tools to machineries in the industrial era, and then now we're in the digital age where it's all about electronics and computing and all these fancy technologies that were introduced over time. All of it was in the favor of improving our lives. But if we consider a bigger picture, right, and we look at the potential history of modern human civilizations, computing started in the 20th century. We could argue that it goes earlier on, but widespread computing really was more of a 20th century thing. And the funny thing is that looking at current predictions, we see a ironic pattern of, let's say, if we look far down into the future of the 50th century, maybe we are a spacefaring civilization by then, who knows. But we'll see that in this long time frame, humans have actually spent maybe 100 years doing things in a very weird way, where we were all just staring into flat screens and then tapping at these hard surfaces to perform what we do best, right? And moving forward into the timeline, you'll see that we have once again come back to what is most intuitive and most natural to us, where our attention is now focused on the things that are happening around us. The work that we do happens around us instead of through a screen. And that's what XR is essentially about. So to draw an analogy, if space exploration is the next frontier to uncovering the unknown, then when it comes to computing, XR is that frontier. Because all the while where we have developed computing, we have evolved from being desk-bound to being mobile with our laptops. And now we could say that even our phones are kind of a computing device where we can do all kinds of work with it. So the question begets is what's next?
Want to ask something here?
Yes.
So, games like Pokemon Go, where you on your camera and then you catch a Pokemon. Is that considered XR?
Okay, yeah, that's a good question. So that actually falls back to this category, right? I was talking about. I didn't go into great details here. I'm assuming we all are quite familiar with these three things. But Pokemon Go is an example of AR, where there's this notion that AR refers to simply augmenting information onto your environment and help you do work with it. So think of it like a display panel that appears in your physical context, right? These days, most AR applications will run on your phone, and it basically brings digital information into the immediate environment around you to give you more information to that area. Whereas, how is that different from mixed reality? That might be the question you might be taking now, is that mixed reality is often the notion where there's a lot more intelligence embedded in it, such that the technology is cognizant of your environment. So let's say if my environment has a table in front of me, and I create a mixed reality application. This mixed reality application will recognize this table and do work with it. So spatial recognition, more smarts rather than just blind augmentation. So that's really the key defining features when we use these terms these days. Yeah. Of course, the lines here can be a bit blurred. We start to see a lot of what used to be AR libraries trying to develop capabilities that lean towards MR now. But yeah, another set of defining traits would be that mixed reality delivers a first-person experience rather than having the users relying on a separate device just to bring out those augmentations. So what I'm referring here is usually head-mounted displays where you can wear this set of glasses and then everything you see is in context immediately. I hope that clarifies.
Yeah, thanks. Actually, I can see a lot of potential for like deep learning, machine learning to be used in this field.
Oh yes,
Especially
certainly.
like MR. MR, you need to recognize the objects. You need to
Correct.
like statistics.
Yeah,
looks quite similar to what like the current trends in deep learning are trying to do. Just that we just need a device to implant the user in the real world. That's the hard.
Yeah, actually, you are very on point with that. That is one of the takeaways towards the end of this talk. So you are already quite aligned to what I have in mind.
Yeah, no, because I do this kind of research.
Yeah.
Okay. Yep.
So if we move forward with the conversation, you'll see that the current landscape points to ever increasing demand to this, and that's really the for the reasons why I mentioned earlier, right? This is really the next frontier, because what's next after smartphones? At some point, I think humans are social creatures. We want better connectivity. We want more intuitive connectivity, where we do things in a human way, where technology moves on a human path with us. So this prediction of the timeline was really envisioning of what the next phase of computing will be like, and with the uptick of these applications, it will accelerate that vision when more people learns the affordances of spatial computing. And we start to see this most evident in this pie chart distribution, where the people who have the least access to computers since the 20th century are yielding the most benefits in XR applications. And that's why a bigger share of the pie is taken, because you see most use cases revolving around those. That's where most problem statements are always found in these industries. And that's also where XR can come in to make the most difference. Education, right, where a lot of this concepts that we learn today, science, engineering, they are all really 3D problems, but we're still learning them through 2D materials. And it's only at a very late stage that you get access to like 3D references, like 3D software and things like that, which is so strange, right? We're learning circuitries through abstract drawings even, and so on and so forth. When your live wire probably runs in a very 3D way around your house, as you can imagine. So all this combined, the bottom line is that when we bring computing to a more spatial level, we are also empowering more people on the ground doing important work, like people in the surgical theaters, people in the remote locations, handling infrastructures, to have access to computing and do meaningful work with it. And that's really what this is going to as a current landscape. So to bring forth what I've shared as more concrete examples, I have extracted some of my past works with the Singapore agency to give you guys a glimpse of the technology. So these two videos here is really, one is about the forensics team, Home Affairs, where they are this is like the trailer of many things, but you can see certain segments they use XR to redefine the work that they do. You guys can hear the video, right?
I think you might have to share the audio.
Oh, okay. Do you know how I can do that? I don't see the option.
I think you need to stop sharing screen, and then when you share screen once more, there's a button on the bottom left that says share desktop audio.
Okay, let me just try that.
But beware, it's sharing the entire desktop audio.
Okay. So if I try to hit the share screen, it will share sound. Okay, got it. Makes sense. Okay, I won't be rewinding the video because I can share this link with you guys and you can watch it actually at your own time.
And to uncover the facts. So where do we stand? We stand with the front line, advancing science and technology, sifting through the smallest of details to quell any unrest.
Engage.
We are the force multipliers, the innovators, and the dream makers, exponentially impacting Singapore's safety and securing our future.
So yeah, what you just saw was a Ministry of Home Affairs application for the forensics team, where they every time they train these new trainees, they need to create these crime scenes, which involves like some blood fluid dynamics. So they actually kind of try to reenact the crime with weapons and body suits filled with blood bags. This obviously is quite an onerous task, and not to mention the cleanup, because all these scenes are like one-time use. So they set it up to one training, they have to clean up and then create a new one next time. So mixed reality comes in to redefine all that by allowing them to augment their regular spaces, like a HDB room, into a crime scene with the use of augmented objects. So I don't think we need to play the other one. This is Crescent Girls School using it for learning. It's also one of the projects we've done. Basically, with spatial computing, you can create really engaging learning simulations that takes the students to otherwise impossible situations that you couldn't do as a teacher in a classroom, and present them with decision-making opportunities that are also learning points in your curriculum. So basically the whole gamification that can happen and the whole immersion that this experience could bring when you combine all these concepts in XR. So that brings me to the final point, right? Well, all the things that I've shared thus far, it may seem a bit far-fetched. I think the problem that we are dealing with today is really this concept called convergence, right? Because why we think that it's far-fetched is only because all these little pieces are not working seamlessly together yet. We already see advancements in each of these fields, XR, AI, cloud computing, advanced robotics. And what does it mean when all of these things work seamlessly together? We see an Iron Man effect where you can really do many things, right? essentially you're like a superhero. So honestly, I feel like we're not that far away from that timeline that I've shared, where we start to compute in a more spatial way, in a more intuitive way, because all of these things are already out there today. And when people start making the effort to look at how these individual crafts can converge, that's where we see the new phase of computing. So I ended with a very visual example of what convergence means in the real world application. So this isn't Iron Man fighting, but yeah, we get to see XR working with all the other things.
Penny walks in on location. She has to set up the space for a product unveil for a group of clients. Enter Microsoft HoloLens, the world's first untethered holographic computer. The device maps the room in order to construct a digital map of the space, allowing Penny to fill the room with holograms. What you see here is next-generation hand tracking. Penny moves the holograms throughout the room in real time and space. The boxes react using physics-based simulations, just like they would in the real physical world.
Sorry, Penny. This may be a bad time, but the client is on an earlier flight.
We're so not ready.
Should we start to panic?
Not yet. Just bring the team in, please.
Windows brings spatial sound, articulated hand tracking, and Samir's own hands into VR.
I can see you're hard at work, Samir, but Penny needs your help.
Yeah, sure thing. Just let me check out this bunker real quick.
Samir, the client is on.
As per usual, your sense of timing is just awesome.
Kai-san, Pennyが呼んでいますけど。
今すぐ行くって伝えて。
Kai joins the conversation as a hologram. Samir also appears as a 3D avatar, which he scanned himself using his phone.
Cute.
I try. So, how's it coming?
It's not. This is the flagship store. It's gotta be unforgettable.
Yeah, not exactly blowing my hair back.
Yeah, the space is driving me nuts.
All right, how about a change of scenery?
Welcome to Think Club.
Imagine the web of the future, where you can draw inspiration from the cloud in 3 dimensions and all around you.
Some inspiration, please.
Namaste.
These bots help them interface with businesses. This one helps them find amazing 3D assets. Kai uses a pen and Samir uses a specialized controller in order for them both to manipulate and design the 3D creation. The team forgets that they are not together physically as they continue collaborating on the design. Penny picks up the eyedropper to grab a color from the physical ceiling in order to make things feel more anchored. Through the conversational bot, we see a real-time translation of what Penny's client is saying.
Impressive.
That went well.
So yeah, this is a feel-good video of what I think will be in our near future. I hope it excites everybody here. And no matter what craft you choose to pursue, I think if you keep convergence in mind, that will be a very exciting adventure to have as a career. Okay, I at the end of the presentation, so I will now open the floor to questions.
Hi, Lloyd. Yeah, maybe I'll just start first. But yeah, so for the rest, if you want to ask Lloyd about his work experience or what, just feel free to go ahead. I think Lloyd is keen to share as well. But today's talk mainly is about some introduction to this space. Oh yeah, but anyway, my question was, just now that video, it is not like the actual product, right? Because like, the Microsoft video.
The last one, yeah.
That one is a concept, right? It's not implemented yet, right?
Actually, the reason why I picked that video, it's that it's something that's really close to what they have today. So in my experience working with mixed reality, I have created physics-based experiences, solutions where your holograms can really react to your space quite well. And we have created collaboration platforms where people with phones and laptops can come in to share the space with you and look at what you're doing and look at 3D presentations. So I could be presenting a 3D blueprint with all the buildings already built in place, and then you could come in and take a look and take. So I would say, well, the video is obviously a marketing ploy where everything works super seamlessly, but it's not that far apart when you can, because all of the pieces are already very achievable.
Understandable. I understand the avatar and the like physics interaction. I just don't quite see how. Okay, maybe it's lacking certain parts. Like how is the headset able to get your gesture information to do everything? You must have some form of sensors on the hands also, right? In order to get this MR stuff working.
Oh no, actually, the whole thing about MR is that the head-mounted displays are already equipped with a whole bunch of sensors constantly looking around you. So they capture quite a huge FOV. And whenever your hands are somewhat in front of you, or even at your waist to chest level, they will already be able to pick up your hand signatures. So let's say you're performing a certain gesture, they will register that and react to it accordingly.
So this is really the end product, which is like a headset can do like detection of the body posture and everything already.
Correct.
Oh, that's interesting. Yeah, I didn't know that. Thanks.
Yeah. So as we continue to progress, I expect this sensors to be way more enhanced, and then it will be able to pick out the fineness of articulation, right? And that will bring us towards that envisioning of a very intuitive computing phase. So yeah, this brings me back to what AR and MR is really about as a differentiator. MR really has all these smarts to help you do work with your physical surroundings and your participants. Whereas AR is usually a one-sided narrative where there's already a very pre-scripted augmented content around you. And yeah, it doesn't care about what your profile is or where you are, and it just tries to augment things on top of it. Okay, so hope that answers the question.
Yep, thanks. Yeah, the rest, if you have any other questions, please feel free to ask them now.
Are there any type of public tools available that allows you to do this?
Oh yes, so in fact, depending on what you're starting out with, if you do use the Microsoft HoloLens, now it's on the 2nd gen. There are news that they are coming out with the 3rd one, but that's still like more of rumors. Essentially, like all game development or interactive content development, you can use Unity as a baseline. So that will already come with a lot of these efficiencies, right, that you can introduce. On top of that, the mixed reality device has a SDK on its own. It's called the Mixed Reality Toolkit that Unity engine supports. So using Unity combined with that will allow you to get into the development the quickest. Yeah. Hope that answers the question. Or do you have a specific device in mind? I can point you to the resources as needed.
Not really, because if you say the SDK is like publicly available, right?
Correct. Yeah, but that's for the Microsoft HoloLens. So if you are planning to develop for something else entirely, then you probably need to find that SDK for it.
I think it's fine. I think it would be pretty widely available if you make it Microsoft.
Lloyd, what do you recommend if, let's say, you want to start coding and trying this out? What's like the cheapest device that one could land their hands on? And
okay. Well, it depends on where you want to go, because the price market for VR, AR, and MR is really quite different. Like AR, as you know, it refers to mobile phone devices these days, right? And that one you can get for a couple of $100s, because even the older models are AR capable these days. VR is also a couple of $100, because even the leading Oculus Quest 2 is like $400 USD, give or take. Mixed reality devices are a little bit more on the high end. Like the Microsoft device can easily be 2,000 something per piece, and then it goes down to the next tier, which is like Magic Leap, which is almost $1,000 per piece. They are the lower end ones, but I wouldn't recommend those, because the brands that are developing those have not really created a good track record of this product. Yeah, like in one experience, I was trying out the Lenovo mixed reality headset. I noticed that the whole interface and stability was a bit janky. Not to mention that the holograms that they rendered were pretty flat in terms of immersion. So you can even a 3D model would not appear very 3D like for you. So there are a lot of limitations with this field because it's new. So the hardware themselves are constantly being improved. And in that sense, depending on which device you get, the experience can be quite different. Yeah, I hope that gives you a better picture. So yeah.
So basically, like VR, AR can be done with handphones, but MR, you probably would recommend the Microsoft headset in order to.
But that will cost a lot more. Correct. Yes.
Yeah, I'm also just curious, because like, you know, in Unity, if you want to do like deep learning stuff, because like, let's say you want to do object recognition, you use like a TensorFlow hub model, stuff like that. I'm not too sure how compatible Unity is with this kind of deep learning tools, because usually it's done in Python. I know Unity has this Python deep learning library that you can export it to Python, train the model, then put it back in Unity. But I'm not sure whether you can do it real time. So do you have any idea on how people do it?
When you want to use machine learning in Unity, you're better off looking at implementations that are grounded on C++, because while there are a lot of algorithms being developed on Python, right? Python environment, there are quite a few on the C++ ones as well. And C++ have easier compatibility to the Unity environment, which is actually coded in C++ under the hood. So if you ever pull like the open source code of Unity engine itself, the construct Unity engine, you'll know that it's C++. It's just that all the scripting interfaces, they accept JavaScript and C#. But what really happens at compile time is that they convert your C# scripts into C++ code. Yeah. So essentially, if you find a ML implementation that is using C++ as its building blocks, then you probably will have an easier time integrating that into a Unity space. Yeah,
I think that should be no issue. I guess TensorFlow has C++ also. Yeah, I have to go.
Correct. Yeah, you need to look around. But more importantly, depending on what you're trying to do, Unity already has some smarts, but their smarts are usually more relevant in the game context. So like, you know, AI for enemy logic, AI for pathfinding.
Those kind of state diagrams, state trees.
No, not even like finite state machines, but like really more complex AIs that you can bring in. Yeah.
Okay.
So yeah, very clear example is this implementation called NavMesh, where they generate pathfinding through a dynamic terrain. So that is well, that I wouldn't call it machine learning, but it's one of those AI algorithms for games. Yeah.
Yeah, thank you.
Any other questions? Okay, I was looking through the chat and I saw Alindia, right? I think you are asking quite an on-point question. So, what if someone does a gesture unconsciously, right? That's a very good question, and that's one of the things that we frequently have to solve. So, from a programming perspective, you can there is definitely a UX consideration where you want to train your users to navigate as intuitively as possible, and there comes a fine line between what is way too common and what is not expected at all, right? So what we usually do when it comes to this gesture capturing is we need to understand whether a certain action will cause a disruptive action. So if it's disruptive, then we want to have a double confirmation, for example. So it's more of a UX question here, and how we can try to create an elegant experience without causing a lot of angst. Yeah, there's no doubt that the device can sometimes recognize gestures unconsciously, unintended gesturing. Yeah, but as long as you design your computing with that in mind, there's usually a work around it. Okay, so I think that's also all the questions here. I don't see any further questions on the text.
Right. Maybe you just check one last time. Okay.
Yeah. Anyone else?
If not, that actually is more or less the end of Lloyd sharing, which is a basic introduction in this space, which is something new actually. I never knew that there was such a thing as XR until I met Lloyd.
Yeah, great. It was helpful. I hope you guys are excited about the vision I shared too.
Okay, if not, I think let's all thank Lloyd for the interesting sharing, and yeah, thank you so much.
Yeah.